Welcome back to the channel. I have made some progress with the build. It's sort of an intermediate stage right now. You've already seen the box, the TFT, the buttons, the wiring and so on. My initial attempt was to mount the sensors for the film back inside this little box that I got from AliExpress. So I drilled the holes and I glued the sensors inside the box. I did the wiring, but as expected, it is extremely difficult to actually keep this in the correct position on the back of the camera. So I decided to ditch it because I wasn't getting what I hoped for, and tried this. So this is 3D printed. It's an initial design. It's wrong-ish, but the baseline, the basic idea is actually correct. Okay, what I did was make this little inner portion embossed, and this should have the dimensions of the film gate. The outer portion was designed to accommodate Zorki 1 camera, so it pretty much only fits the Zorki 1 and Fed 1 and maybe the Leicas. In my future revisions, I will actually design it in such a way that it should fit any 35mm camera, as long as you obviously have access to the rear of the film gate, and as long as the actual film gate has these dimensions. The dimensions are pretty generic, so you have 23.7 on the height and 35.5 on the length, so just a tad smaller than the actual film gate. That is not 36 by 24 anyway. It has 3 little holes. I think they are 0.8 millimeters in diameter. This one was a failed print because the holes don't go all the way through. Obviously you can use a set of very fine drills and poke the holes, but I had 2 of them, and this is one and this is the other. On the other one, the holes go all the way through. These are a bit larger than the ones on the other little piece of plastic, because I thought light was not getting on the sensor, and this is another very small chapter of this video. Okay, on the other side you have the sensors that are glued with glue gun, and all the wiring, so resistors, capacitors, pretty much. I tried pretty much to connect all VCCs, so all the power for the 3 sensors in one, and I think the VCCs are this blue wire. I wasn't able to correctly color code the wires because I didn't have enough little wires of the same color. Anyway, doesn't matter. So this is VCC, and the green one I think is the ground, and then you have purple, orange and gray for the actual signal. I think you can call it signal for each of the 3 sensors. Obviously everything is connected to the board. All right. I flashed the board and I tried to start it up just to see that it was not working under any circumstance. Actually, I think it worked like once, literally once, one time, one shutter test. And after a couple of days of going back and forth with Nige, the guy who designed it, we kind of managed to figure out what was going on. Apparently, the light source is extremely important. So I bought this LED light, video light from AliExpress using the link that he provided. Now, apparently, not all of them are built the same or something like that, because this one is not working. It turns on nice and bright, but it flickers. So the only time I actually managed to make it work was full brightness and the setting for color temperature to the coldest setting, which is probably 6000 Kelvin. And it only worked once. Then I tried to use my other LED panel, the one that I used for digitizing film. I think it's a Raleno from Amazon. It's a bigger one. And just the same with the power output to maximum and temperature to the coldest setting. It was working once in a blue moon. Then I suspected something was wrong with my soldering and with my wiring, so I got everything off and redid all the wiring and nothing. Then I suspected that the little sensors were not centered, and this is the little chapter that I was talking about. On my board, on my thingy, that is actually the front of a box that I will design later. So this part goes on the film gate, and it has the 3 little holes that were supposed to be 0.8. On the other side, I drilled, like halfway through the thickness of the material, I drilled something like a 2.5 or 2.0, I don't remember exactly. So a larger hole that I tried to keep centered with the smaller hole. And I did that in order for the lens, the little lens of the sensor. So this is the sensor. And if you can look closely, you see, it has a little lens, the dome-shaped thingy in the middle. And it also has like a raised lip here, but I trimmed it down so it could lay flat. But I wanted to make a larger hole on the inside of this piece so that the little lens could go in and the surface of the sensor would lay flush. Now, I did measure as much as I could with my other caliper that's more precise. I did measure the diameter of this. It says 1.3, so I probably used the 1.5 drill. But even so, I wasn't very sure that it was sitting properly. Now, I re-glued the sensors on this board 3 times, and the last time what I did, I used the included alignment utility. So basically, let me power this thing, and hopefully I won't forget to talk about my build mistakes at the end. So when you plug it in, you get, let me turn off the lights. This should do. Okay, so you get a list of what the buttons do. For instance, the green button is for the light calibration or something, light meter. I have no light meter, so light meter not found. The red button should go to optical tester. I don't have the optical tester connected to this one because I built it as a separate unit. The yellow button, I don't remember what it does, but Probably nothing. Okay, the white button should be, well, right now it seems that it does not go back from the optical tester. Okay, bug found. I'll just restart it. So yellow button to reset averages. Yeah, that's what the yellow button does. White button to see the averages. And black button for setup and alignment utility. So if I press the black button, I have white for factory reset, yellow for swap sensor type, which means swap between original sensor and new sensor. It all depends on what kind of sensors you have. For instance, it now says blocked, so it sees no light. If I push on the yellow again, it says seen, because they see the light that's still on. If I, no, actually it says seen because it's the original. Goddamn wires. Let me try with my flashlight. So in my case, I need to use the new sensor set, because if I flash a light over the sensors, they will go blocked. See? That means when they see light, they go in a blocked state, when in fact they should be in a seen state. And now they are in a seen state, although they see no light, because the ambient light is too dim for them to react. Okay, if I go to new sensor set, they say blocked. So this is the correct option for me. Then you have green to toggle between horizontal and vertical shutter. In this case, I will stick to horizontal for now. Red to see button legends. Okay, and again, black to return, but now in the setup and alignment utility, you actually get the alignment utility, which is this one. So sensor 1, 2, and 3, or 1, middle, and 2. And it tells you if the sensors see light or not. And as of yesterday, the last revision of the firmware, it also tells you if the sensors detect flickering, because if they detect flickering, the tester will not work. In this case, I will use this, and this is what happens. They toggle between blocked and seen, and all three show flicker. Even if I increase the light intensity to the maximum, they remain on seen, so they see the light, but I have the flicker warning. And as it turned out, it means that this little thing is useless. All right, but what I did, I used this utility to actually glue each of the three sensors in such a way that each individual sensor would show me a seen message in that position. So I placed the sensor, moved it around until I saw a seen that was constant, and so it wasn't toggling back and forth, and then I applied the glue as a final resort, because I really did not know what else to do. Okay, so where were we? Little LED light panel didn't work. Larger LED light panel didn't work. So my next option was, okay, I'm just going to try a light bulb, because why not? So I tried an incandescent 100 watts light bulb, which is pretty much illegal nowadays. I mean, you can't buy it anymore, but I have a little stash bought back when I had big plans of fixing all the amplifiers and musical stuff. So I needed some kind of protection between the mains and the amplifier in case something was wrong when turning the amplifier on. The bulb would act as a kind of current break, so the amplifier wouldn't expel its smoke. So I tried a light bulb and it worked, and that was a very fulfilling moment. But it works, but it is extremely bright on one hand, and it's not kind of shielded like this panel, so it goes all the way around, and it gets extremely hot. So I decided that was not a good idea, and my next option was to try fluorescent light bulb. I had one like a 6 watt fluorescent light, I think, or 11 watts, something like that. I tried that one and it did work, but only if the sensor was very, very close. And that might work for, I don't know, a Zorki, but it wouldn't work for an SLR, which is a lot thicker. And then I turned to a bigger one. I don't know how many watts it has, but it's big, meaning it's this big. Oh, look, 45 watts. And this one actually works. Now I will need to try and think of something that could accommodate for such a big light bulb, or maybe try maybe smaller ones in, I don't know, 3, 4, 5, 6 in a row or in a matrix, and maybe a diffuser in front of them, and maybe a Fresnel lens in front of the diffuser. I don't know. I will try, I will make some experiments. I have no idea. But this one worked. And I will now try to actually show you how it works in this state, and then I will describe my let's call them future plans, meaning what I want to modify and how I want this to look, and how I think I can get rid of these wires. All right, let's see what I can do. Well, I guess that's as good as it gets. I'm sorry for this disaster, but I don't really know how else I can show you. And I will try, or better said, I will start with a Zorki 4 unserviced. The rangefinder is rattling inside, so it's on my to-do list. All right, and I will try it on 1/25th. For some reason, actually I don't even remember if the higher speeds worked. Okay, so the sensor stays nicely on the film gate, and let's see what it says. All right, so on 1/25th I have 250 here, 128 at the middle, and 128 here. Actually, the actual values are 188, 158, 119. So basically the shutter speed, actual shutter speed as it is recorded by the film, increases as the curtains move to the left of the camera. And now I'm going to take more readings so that the shutter can make a couple of averages and see how they changed. Okay, good enough for the first camera. Actually, I think this is the best solution. And this is the amount of information this shutter tester can offer. It's a lot. You can also extract, I don't know how, I'll find out, it doesn't matter right now. You can extract this information and export it to your PC, export it in a file, keep it, store it, share it, whatever. So you have the following. Sensor 1 is the one on the right of the camera. Sensor M, middle, is obviously in the middle. Sensor 2 is on the left. And you have the shutter speed, let's call it speed, in milliseconds. It says uncal, probably uncalibrated. I don't know what exactly that means. So you have three values. Then you have the shutter speed in milliseconds without any other remarks. And you have the three values. You have the shutter speed in seconds for whoever wants to have both variants. You have the shutter speed as a fraction, so closer to what we are used to see. Deviation from center, obviously you have 0 in the middle because that's the center. And deviation from center as stops of light, or fractions of stops of light. So for 1/25th, it says no deviation from center because it's probably too small, although it should have shown like a minus 1/3 of a stop. It doesn't matter. Then you have the nearest shutter speed, which is 1/25th. In this case 1/28, because that's the actual fraction of a second. Deviation from nearest in actual something, I don't know what unit of measurement is this, and in full stops or fractions of a full stop. Then you have the travel time in milliseconds for curtain 1 and for curtain 2. So curtain 1, the travel in milliseconds from right to middle and from middle to left. So you basically kind of have to have them add them up, right? So you have 21, which is this value, and then you have the same on the second curtain, and you have this value. So from the get-go there is an imbalance between the two curtains, and this imbalance will translate as shutter capping for the highest speeds, which in fact the camera actually does. It does cap on 1/1000. So this is actually a good indicator, although it's not a given. It might not shutter cap because the shutter doesn't behave in a linear manner. All right. Then you have curtain bounce, none, so no curtain bounce on either of the two curtains, and flash input not detected because I would have to have a flash port connected to the camera and to the device, which I do not have for the time being. And then you have the averages. In milliseconds, in fractions of a second, deviation from center, deviation as a fraction of a full stop, and the curtain travel time for the two curtains, curtain 2, curtain 1. It's a bit much from an information point of view. I am totally sure that in a future iteration of the firmware, based on our feedback, so mine and whoever builds this device, things will change. So maybe we could have an option of maybe two display types, simplified one and the more in-depth one, or maybe three display types, whatever, it doesn't matter. So I don't care about uncalibrated shutter speed unless I will learn that it can tell me something about the actual functioning of the shutter. I don't know for the time being. I don't care for the shutter speed in seconds. I mean, milliseconds is okay with me. I know 1 millisecond means 1/1000th of a second. The deviation from center, I'm perfectly fine with this one, expressed as fractions of a stop of light. Nearest shutter speed, personally, I don't care about this because I'm testing the camera, so I know what shutter speed I'm on, and if the error of the shutter, of the actual shutter, is too great, it will actually show you a different shutter speed here. So perhaps you are testing 1/1000th and the shutter is very slow, and the shutter tester will give you 1/500th of a second, the nearest, and the deviation from the nearest will obviously be calculated for that 500th, and maybe you'll get a third of a stop error when in fact you are one stop and a third. So this one I don't really need. This one I don't really need. This one I do need. So deviation from, but in this case, maybe it's too complicated to actually set the shutter tester. So you would need to tell the shutter tester what speed you are testing, and then it would tell you the deviation from that set speed. That would be an option. Curtain travel time, super important. I would also add the combined. So maybe I would add the combined of these two values here on the middle. It wouldn't be relevant for sensor middle, but it would be relevant so I wouldn't have to add them up. Although you do have the results as an average, and that's okay because you shouldn't ever adjust based on one measurement. These are not reliable machines. You need an average because there will be a difference between the readings. All right, but yeah, a lot of information that you can use to understand what's going on and what you need to do in order to fine-tune as much as possible your shutter. All right, so this is again 1/25th on a Zorki 4, unserviced, all rattly. It's not that bad. It's not that bad. I mean, in the middle is actually too fast. This one is too fast. This one is the closest to the actual speed. And that, as an example of conclusion that popped in my head after seeing these values, this camera has been adjusted in the past, meaning that somebody pumped up the tension in the curtains. That's what this means. Because if it was set correctly in the factory, let's assume that it was set correctly in the factory in 1973, and nobody ever touched the camera, meaning inside, from 73 to 2024, adding up all the dried grease inside and the dust and whatever, all the speeds should have been a lot lower. So probably somebody used a screwdriver to do stuff to the camera. And now my beloved Olympus OM1 is next. I have this camera for many years, at least 10, but I think 12, 13 years, something like that. I only used it a couple of times for some reason. I always tend to go towards other cameras like the Minolta XD7, which is actually my all-time favorite SLR. So not much action for this camera. I did not service it. I am too scared to open it up because I don't want to butcher it. I will someday. So the shutter is probably untouched, not in this sense. Ooh, this one has some creases. In the sense that nobody touched the inside of the camera for at least 12 years, if not more. I suspect a lot more. Okay, so let's see how this guy fares. And yellow means reset averages. Although I'm pushing yellow and nothing happens. I'm not really sure what's that all about. Yellow swap, white factory reset. I don't want a factory reset, I just want these to... Yeah, I don't know how to... Okay, let's factory reset. Okay. Lights off. Sensor on the film gate. Light bulb on. And this will be a little more tricky with the back door, but I suppose I can take off. And something happened because it kind of saw light and everything went to bloody hell. Okay, let me reset it again. All right. Now the camera is set to 1/1000th of a second. Let's see what happens. Up there you have the number of shutter releases. Now I'm at 4, 5, 9, 10, 11. All right, so it's a bit slow, but it's decent for how old it is. And actually today, while I was messing about with it, the values were even better. But now let's maybe you push on the button and then when you first let's see, let's try 1/25th. Quite nice. And indeed, the averages have reset. So push again. Now I'm at 1/250. This one is slightly slower. Closest on the right side of the camera. but it's okay. Reset, and now 500 of a second, which is more like 400. But that means a third of a stop, so that's all right. All right, and see, deviation from nearest, third of a stop, so it's all right. For this side of the film gate, the deviation is actually lower than a third of a stop, so it's 1462 instead of 1500. It's all right. Probably with a bit of CLA, with a bit of oiling here and there, it should work pretty nice. And let's try 1 second. Let's see what happens if I try 1 second. Well, that's not bad. So I get 0.95. All right, and this was an error. I'm not really sure what it means. It's something like something. I don't remember what it is. All right. Lights on. This one off. Basically, this is what this shutter tester does. I did use the older version quite a bit, the one that used lasers, because that's what the guy kept telling me, and I kind of kept not listening to him. Lasers use collimated light, and that's why the sensors always respond, but it's a pain to align them. So for me, as a DIYer, it would be a lot more tricky to actually build a rig like the one I showed you in the last video, with the lasers on one side and the sensors on the other side and the camera in the middle. And therefore I very much prefer this option, that I can also design to accommodate for different cameras, meaning that I can make several of these little boxes and just swap them depending on what my needs are. All right, I will disconnect the power so that I can now tell you what I need, what I want to do in the next steps. First of all, the distance from the USB socket and the wall of the box is so short that an actual cable, you can't plug it in without making a hole, because it won't bend. I can't put this one further to the back, obviously, because of the expansion board. If I put it this way, so if I shift it 90 degrees, I won't be able to put these wires in, okay, because this distance will be equal to this distance. The only solution I see right now is to actually buy from our Chinese friends, of course, a couple of USB-C sockets, but without any wiring. So just the actual connector and the little board on the back of the connector, and I need two of them. One will be connected to the actual board, and the other one to mountable USB-C connector that will be mounted on the side of the box, and then jump wires between the two of them, and hopefully that will fix the problem. All these wires, I probably will have to live with them. I don't like them because they are very stiff. So another option would be to actually buy wire, like color-coded wire. I don't know what kind of gauge I would need, probably something very thin, and ditch these and use those instead. So kind of do something like this. I would need to thin the ends so the little screws can bite on the ends. That might be a better option, and I could also custom cut each wire to an appropriate length. All right, that's one. And the most tricky of actually not tricky, the nicest thing will be the connection between the actual sensor box and this box. And the option proposed by the author was to use an Ethernet port, so Ethernet connectors on both. Actually, you don't need to use the connectors on both this box and this box. You can only use one on this box, and on the other box you simply solder the wires to the components. That would work. And the big advantage of using an Ethernet connector would be that you'd also be using an Ethernet cable, I think, and that is shielded, and as it seems, interference between these little wires can cause all sorts of issues, wrong readings, and actually not wrong readings but errors. My idea is to actually use DIN connectors, so the connectors, the round connectors with many pins, and you can choose from 3 pins to 9 pins or something like that. Now for a sensor box I need 1, 2, 3, those are the sensors, and 2 more that are represent the power, the VCC, and the ground. Otherwise I would need to have 3, 3, and 3. So I could also use a 9 connector, a 9 pin connector, and each wire would go in its separate way. But I think this version with 5 is actually better. So I have 3 for the signal, and then 2 that are common among the 3 sensors for power supply and ground. And in this case I would go for the 6-pin connector, so I would have 1 extra pin that I could actually use to attach a flash port to this. So imagine that you have a flash socket on the camera here. So I would place the sensor on the back and the little wire for the flash in the socket, and you can have the socket here, you can have it here, you can have it here like in the Soviet cameras, you can have it here like in Leica Barnack style bodies. I think it's cleaner than to use a longer wire from this box to the flash port. That is also doable, but on the other hand I would need a flash connector for every sensor box, and that's not really nice. And on the other hand, if I only have one flash connector, I would need to have another socket so I can take it out and put it back. Yeah, I might just attach one to the box. Either way, so 5 pin or 6 pin, it should be enough. And obviously you can find these on AliExpress super cheap, set of how many you want, like 10 pieces, and you can choose male female, female female, male male, whatever combination you want. That's super nice. You can buy them in pairs, so I can get female for this box, a male for the cable that gets out from the sensor box. I will buy, I don't know, 3-4 pairs, so I can make 3-4 of these, and that should be very, very clean. My goal is to have a box, so a box that only has the display and the buttons, and I might also buy another box, so hopefully the second time I make this cut it will be straight. As for the buttons, I could get rid of this one because my optical shutter tester is separate. I could omit altogether this one, so this little hole that I made for that potentiometer, which is unused for the time being, and I would have a simple Tetris like half of a cross in buttons. And I would probably buy all black buttons and somehow label them, or simply memorize what each of the buttons do. And I could also rearrange the buttons in such a way that they make more sense to me. All right, what else? Yeah, so that's my goal, to have a box that only has the display and a couple of buttons and a couple of connectors on the side. A connector for power, so an USB connector, a connector for the actual sensor box, a connector for flash, and in the future maybe add more functionality if the author adds more functionality, because I'm, as I said, I'm a little monkey. Monkey sees, monkey does. That's all. All right, I think that's all I wanted to say. I will probably at some point, sometime in the future, it's not really my priority right now, I will probably add another episode to this build series with the actual finished product. And when I do have a finished product, including this box, I will upload the 3D files on Thingiverse, whatever it's called. So anyone with a desire and a 3D printer can build this shutter tester. All right, thank you for your patience. Hopefully you find this an inspiration. It's all in all an easy build, especially now that maybe you know what to do and what not to do. And it's an ever-evolving build. And again, the author, this guy, he's awesome. I mean, he will answer your questions, he will listen to what you have to say, and he will improve on the design so that it gets more and more and more functional. And for this price, you can't beat it. The information is free, the materials are cheap, and all you need is a bit of elbow grease and you'll have yourself a shutter tester. It's not the prettiest, but who gives a fuck? It's important that it works, and yeah, that's all that matters. All right, thank you. I will see you next time.